All right, so good morning, everyone. I'm Ryan Huber. I work for a company called Risk.io. I'm not going to spend too much time on that, but if you're a Rails developer and want to work on cool security stuff, we're hiring. So come hang out with us. My Twitter handle's Ryan Huber, which is really creative. And I'm actually, this slide's still in here from a long time ago, but it's a PSA that I continue to give. Dropbox plus ENCFS plus Keynote 6 equals corrupted presentation. So do not ever edit your Keynote presentation if it's in ENCFS inside of Dropbox. I lost about 3 hours of work with that. So about me, like I said, Ryan Huber, I work for Risk.io now. I've been there for about a year. Previously with Orbitz.com for about 11 years. And before that, a small ISP, which is where I'm sure a lot of us came from. I'm also into computers and bikes, just like that one. There's no contest today, so we'll skip that. So what are we going to talk about? We're going to do a quick intro to app denial of service, a quick attack demo, move on to some mitigation strategies, what you can do to help prevent these or mitigate them. Talk about Bouncer, which is a small framework I've written to help defend against these attacks, and then a recap. So what do I mean by 99% or running at 99%? So I think you should strive to provide service to 99% of your users and even, maintain the ability to do that at 99% utilization. So you really need to know where your application is going to break, and somewhere in that chain of services it's going to break. And somebody, if you don't know where that is, somebody else will find it for you. We're not going to talk about network denial of service today. We are going to focus exclusively on application denial of service. So quick survey. How many of you have been the victim of a denial of service attack? All right, we've got a few. How many of you have launched a denial of service attack? A few more, not surprising. So let's talk about an application denial of service attack and take a look at a demo. I think it's important because I don't think a lot of people really know what these look like until they experience one. And that was definitely the case for us at one of my previous companies. We were hit with one and just had no idea what was going on. So the goal of an application denial of service is really to exceed your capacity to handle requests in some form. That's it. That's what it boils down to. And some of the characteristics are it's effective with few attack resources, right? So disproportionate attack. You can do this with one laptop to a lot of sites, and that's really dangerous. It often targets slow operations. There was a demo yesterday that really talked about using slow operations as a way to finding slow operations and attacking those directly, being a very effective attack. It can be difficult to detect. You don't necessarily need to flood the target with a lot of traffic, meaning they can really hide in the noise, especially if you're a very popular site. And there's no easy off-the-shelf mitigation. I mean, you can get maybe Cloudflare, someone in front of you, and they can help, but it's not just a simple buy a device and put it in line. So you can further break this down into a couple of categories. And some of these attacks go after your web server, right? So they look for flaws or things in Apache that you can exploit. And a lot of them also nowadays look at your application. So what are you slow at? What are you slow in responding to? And this will be the code you've written that runs under Apache. First off, let's look at Apache. And I want to clarify something here. I'm not picking on Apache, but I'm picking on Apache. So Apache is what I'm going to use in most of the demos on this talk, and there's a very good reason for that. It's what a lot of people use. Show of hands, how many people in this room use Apache right now? Okay, so that's a lot. That's over 50%. So the number we care about in Apache is max clients. I'm sure you're all well aware of this number. And what happens when we exceed the max client number? Nothing. Nothing happens because we can't do anything. No new requests. So hitting this number is bad, and we want to avoid this. So let's talk about some of the attacks, some of the slow DoS attacks, especially the web server ones that are very popular now. One of the first ones was slow LoRa's, which I think was introduced by someone in the room. I'm not sure who. This attack would connect and just send a header or part of a header every X seconds. It just did it really slowly, right? And the web server would basically wait indefinitely for you to send whatever your set of headers were. And before this attack, I don't even think most web servers cared to cut you off at any point. So you could just hold this open indefinitely. There are mitigations in Apache now that make it a lot easier to defend against this, but it's still a rather effective attack depending on configuration. And you just do this over and over, so you open a lot of sockets, which is really easy to do. Yeah, question?
Do any of the major load balancer vendors deal with this problem? Because you're technically terminating on the load balancer before you hit Apache.
Yeah, I'm sure most of them do at this point. I'm not really aware of sort of the layout. I'm sure like F5 and the like, cut off these slow header attacks pretty quickly. So the difficulty of this attack, I would say, is pretty mild. I think anyone can download about 10 different tools that can do this attack, and /run, boom, done. So this sort of evolved into a slow post attack. This came out a bit later, and this was, just find a form and submit to it really, really slowly, right? And they're going to sit there and wait forever. It's going to maybe look like a modem, maybe a bit slower, but still a very effective attack, and you're just holding the socket open, right? So what you want to do in these is just keep the web server talking for no good reason, and this one's also quite effective. And then slow read became popular, and slow read is quite a bit harder to defend against, because slow read is actually asking for a page legitimately, and then what it's actually going to do is probably shrink the TCP receive window and read the page as slowly as it possibly can. And when you do that, it becomes really hard to differentiate between someone that's just on a terrible connection and someone that is attacking. So this one's also pretty easy. The tool I've used in most of this is slow HTTP test, which kind of does all of these attacks. It's a really handy test tool. Let's look at a quick demo of what one of these attacks looks like. So just to give you an idea, this, let me show you this. So pane number, well, this one here, this is connections to, well, let's worry about this one for now. The bottom one is connections to my actual Apache server. So this is just running netstat and how many connections do I have open at a time. And to demo this, we're going to use my really amazing chat app called FeebleChat. It's vulnerable to pretty much everything you can think of. So this 169 is actually bouncer, so we're going to start off over here. So I'm just going to load the home page, and there we go. We have one connection. And the way browsers work, it's actually going to hold that connection open and try and do a few more requests through it. And if we don't hear from it in a while, we're going to close that again. So pretty standard stuff. Now let's see what happens when we fire off slow HTTP test against that web server. So there we go. We're going to open, by the way, the parameters are open 2,000 connections at a rate of 100 a second. And as you can see, my max clients must be set to somewhere around 250. You can actually open a few more sockets than max clients. They don't really do anything, but this number will jump up pretty quickly. And if I go back over here, well, FeebleChat is feeble. You can't do anything at this point. So as soon as I close this, there you go. Everything loads perfectly again. It's super simple, and that's really the danger of these attacks, right? I don't need any amount of bandwidth to do this. I don't really need much of anything. I can launch this attack through Tor, and you'll probably never figure out who I am. So, it's a particularly insidious class of attack. So let's go back to this. So let's talk about application denial of service in relation to your app. Now, these can be a more targeted attack, right? And the goal here is often to repeatedly execute expensive queries. So we're going to look for something that just taxes your database, web server, whatever behind the scenes. You can also hit large downloads, because those just take time and tie up connections, right? So if I can download an ISO from your site, whatever, any big file. exceeding a backend connection pool. So maybe this is the connection pool between your front-end web server and your database. And maybe I can hit that, and maybe you have way more web servers than database connections available, right? That's a pretty good target as well. And creating too many sessions is an interesting one. And this is actually where my introduction to app denial of service began. So if you're doing one of these attacks, right, you're probably not too concerned about cookies and keeping sessions. But the web servers are concerned about that. So every time somebody hits a page that generates a session, that's going to generate something in memory on one of your backend servers. And at some point, depending on your session time to live, you're going to run out of memory, right? So this actually probably wasn't technically an application denial of service attack that we were hit with, but it turned into one because we were trying to hold all of this data in memory, which, at a certain point at 250,000 users, we couldn't do anymore because you just don't have that capacity. Let's talk about some mitigation strategies, and I'm just going to go over a few quickly. So in Apache, there are a few things you can do with mod security, mod request, timeout, mod QoS, and these are pretty effective. But one thing about them that I didn't necessarily like is that they're confined to a single Apache, right? And out of you that run Apache, how many of you run more than one instance of Apache? Right, so quite a few. So if we're defending on a per server basis, that's a good start, but it's not necessarily the most effective way to defend against these. You can also set up, so in one of my talks, somebody raised their hand and said Varnish sucks. I've never used Varnish. I don't know if it sucks, but it's another potential strategy. Put Varnish in front because it can probably handle a lot of connections and any form of reverse proxy. Let's talk about some other strategies. Keeping slow pages behind login is a pretty good one. So if I require the user to log in, at least they're a little easier to identify if the slow pages are behind login. Limiting posts. If I don't need you to be posting, large amounts of data to my website, I should probably prevent that. Don't generate sessions on get is related to what I said earlier. If somebody can hit your homepage and generate a session, it's pretty easy to use up a lot of memory on a back-end, session pool. Leverage a CDN for larger static content. So use Akamai if you can afford it. That's a pretty good strategy, and they're really good at defending against denial of service. Change your web server software. Some people are going to boo that, but you can change to Nginx, and it's pretty darn good at handling a lot of connections. It's not any kind of silver bullet, but it is better than Apache at defending against these attacks. I'm not going to say it's better than Apache overall. And finally, optimize your code. So if you don't have a lot of slow pages, it's a lot harder to execute these attacks. So, if you want incentive to make your web stuff faster, this is one. Let's talk about identification, because I think identification is sort of the goal here. You want to identify the bad actors as quickly as possible. So does anyone have ideas on how we might identify, who's launching a denial of service attack? Listen to Twitter. I don't have that one in here. Anyone else? Connections, total connections. Anyone else? All right, we'll move on to the slide with all of these. So this isn't comprehensive, but this is a decent list of things you can look for. User agent's a pretty decent one for a low-level attack. Sometimes you'll see a lot of, say, wget, or something really obvious, something that is not a real browser. Hitting the same URL over and over can be popular depending on, if it's a really simple attack, maybe they're just hitting your homepage over and over, or an individual link that is slow. No refer. By the way, I don't know, how many of you know the HTTP spec and know that that's not how you spell refer? Yeah, it's a fun one. So no refer, if we're seeing someone hit a lot of deep links on our website and they never ever refer, that's at least a bit odd. It may be a bot, it may be, it may just be a scraper. Hidden links are a fun form of identification. So maybe put something outside of the view pane that only something crawling your website's actually going to click on, right? No user's going to see it, but if somebody hits that URL, that might out them as a bot that's just crawling your website. GeoIP is good and bad. GeoIP is notoriously out of date, but GeoIP can definitely be used in some instances. Ignoring cookies and sessions is a decent one. So if you hand them a cookie and they never hand it back to you, that's at least a bit odd. Maybe not for people in this room. You might browse that way. I'm not sure. And missing common headers. So if you sort of profile what a browser normally sends you as far as headers, and then sort of hash that list of headers, you can really start to see things that pretend to be Internet Explorer, right? Request timing is pretty simple. If all of these if this host appeared when the attack appeared, that's maybe a decent tip-off that this is, part of the attack. Now, there may be some other people that came in around the same time, but the numbers are probably going to skew toward the attacker. First time seen is a similar thing, so we'll skip that. Proof of work. So maybe give the browser something to do and then take a look at the result. So, a lot of these attacks, they won't execute JavaScript. So if you give them a little JavaScript something to execute and then compare that to something you've pre-computed on the back end, that could be an effective way to at least see if they're executing JavaScript. If modified sense, I talked about this with Sergey, who wrote Slow HTTP Test, and I can't remember if we decided this was useful or not. And the last resort, and I really do mean last resort, is a CAPTCHA. Does anyone know why a CAPTCHA is a last resort?
Does it work?
Okay, 2 reasons. The other reason is it really sucks for user experience. I mean, you're going to drop so many users when you throw a CAPTCHA up. Just don't do it. I mean, if you can avoid it, avoid it. So let's talk about a real example, and this is something I may or may not have seen at a previous employer. So this was a German website, and the denial of service came from about 100,000 hosts, which is, I guess a medium attack these days. We saw about 3 requests a minute, and they were hitting random valid URLs. So they'd actually crawled the entire website, and there was no pattern to what they were hitting. And 3 requests a minute, we'll say, was pretty normal for this website. Does anyone have an idea of which of those strategies from the previous slide, I'll hop back to it here, which of these would be most effective against that attack? What's that?
The slide isn't where you think it is.
Oh, thank you. So any idea which of these were most effective against that? What's that? We weren't that advanced yet, unfortunately. That idea came later. So user agent and refer were both very useful here, but let's go back to this. What's the first thing in that list of? Yeah. So GeoIP in this case was pretty good, and that's rare. Most companies are global, but in this case it was a German website. It ends in .de, and so we saw an uptick in traffic from a lot of hosts that were outside of Germany and Austria. Right? So right away you can flag those as at least suspicious. Now this is a unique case, but it's something to keep in mind. You have to adapt to sort of what's happening there. So let's talk about Bouncer. And Bouncer is just a really simple framework I released to help deal with application denial of service attacks. Bouncer is written in Node.js, and it's inspired by NetFlow. Any network people in here that are aware of NetFlow? So NetFlow is something that basically is only concerned with sort of headers and not payload, and it's a really cool way to look at your traffic, and it's pretty quick. So first question, why Node.js? Because it's hipster hacker approved, right? If I want to keep my hipster cred, Node.js is one way to go. He's probably moved on to Go at this point, so I may have to catch up. Seriously, why Node.js? Well, first off, it's asynchronous, so we can hold a lot of connections open that really don't do much. This is very different to Apache's sort of forking model, right? Because these connections are mostly handled by the kernel. I don't really have to worry about servicing them unless there's data. It's really fast when your task isn't CPU bound. It's obvious. There's a great library already written called Node HTTP Proxy, and so this is something that was really leveraged. And the first iteration of this idea was written about 3 years ago, and Node HTTP Proxy was already, pretty well established at this point. So it's a really extensible, well-written. I think they say battle-hardened on their site proxy. So JavaScript is a well-known language, for better or worse. And JSON is the native object format. So I don't know about you, but I kind of like JSON as a way to pass objects around. It's pretty concise, and unlike XML, it's kind of readable by humans, so that's nice. Some of the goals were minimal code, small memory footprint. Why a small memory footprint? Well, also because we want to run it maybe on the same server we're running Apache, and we really don't want it bumping up against Apache. So, having a small memory footprint is pretty good there. Fail open, so if this thing loses connection to its downstream sort of aggregator, we don't care. We just want to pass traffic. We don't want to block anything. Works in the cloud, so you can stand this up on an AWS instance. That's kind of important. You can't. It's really hard to get a network device into AWS. So, or expensive. I don't really know. I haven't done it. JSON again, because I like JSON, and decisions made outside of the proxy code. So this proxy itself is actually really small and tight, and we don't want it making any decisions on its own, because that's CPU time, and that's time it could be stopping the bad guy. So here's the architecture, and this may be slightly misleading. It's not a one-to-one between these proxies and consumers on the back end, but out here we have the internet, the cloud, and we have things coming in and they hit these proxies. And when they hit the proxy, they're gonna generate some data, and they're gonna send that to an aggregator. And then on the back end, there are these consumers. The consumers are what you would write as the defender. And when I say write, the code is really simple. Like anything you can do that can, or any language you use that can consume JSON and do something useful with it, can signal off of this stuff. So it's really easy to write these. And so it's really simple. They sit in front of the web server, and like I said, if the connection between the proxy and the aggregator goes down, no big deal. We just keep passing traffic. So this is the message format. This is sort of what it looks like. These are the messages that the proxy is passing down to the aggregator. And as you can see there, we have a timestamp in milliseconds, and we have an event type and an incoming host. And then once we get an actual request, we send a request event, and at that point we actually assign a UUID to it. The reason we do that is then we can correlate events back to their end time. So we generate that UUID, it's random, and then you'll see the next type of event is an end event that signifies, we finished this, and the delta between those two times tells you how long that event took. So proxy.js itself is just a reverse proxy. It has an array that's its own blacklist. It also has something called a gray list. And a gray list is something that would allow me to block a particular URL per host, but not necessarily the entire website. So you can sort of say, this person's a little bit suspicious and they're hitting this link a little too much. Maybe I'm just going to stop them from doing that. But in a lot of cases, there might be a huge NAT or proxy with actual users behind it. So you don't want to block your entire website. So this gives you a little more flexibility in what you're blocking and what you're stopping. It has a disabled URL list. That's what's used with the gray list. Yes?
Does it support device identification or just IP address?
So right now it's just IP address, right? That's really probably define device identification, I guess.
Threat metrics, iOmation, all the different people that are doing tagging and fingerprinting to generate a device ID.
Yeah, so it doesn't do that now. It definitely just it leverages IP to make its decisions. So it's 236 lines of code, really simple. Node.js, Node HTTP proxy was really useful there. And it also has dynamic header and request timeouts. And those are useful for attacks like slow Loris, because what I can do is change my header timeout dynamically across the board. So if somebody's hitting me with a header attack, I can just say, okay, for now, I'm only accepting headers within the first 5 seconds of the connection. And when I'm not under attack, I can just bump that number. And when you send that command out to all the proxies, it's instant. And then when you switch it back, it's also instant. So very simple. Request timeouts, same kind of thing. I can just set a hard stop for somebody downloading from me. So somebody doing a slow read, I can say you have a minute to read any page on my website for right now. And again, that lets you sort of react to the attack very quickly. So what does it do? It closes blacklisted sockets immediately. So why even send them a proper 4XX, response code? I don't really care. If I've decided they're a bad bad actor, I'm just going to close that socket immediately. Doesn't matter. Monitor the total time to send headers. So for each connection, I'm looking at how long it's going to take them to send that and the end of the response. Assigns the UUID, and then it forwards that data to the aggregator. Yes?
Instead you close the socket, you actually send a full, like...
I don't do it nicely. So there's some added benefit to that, which is kind of funny. If I don't close the socket, it is still in kind of a funky state. But a lot of these attack tools actually start going crazy on their CPU, right? So actually, it's not a reverse attack, but it really, like, their CPU will peg at 100%, trying to send data across a socket that I'm not communicating on anymore. Does that make sense?
Wait, so you're saying you don't actually send a pin or a reset, you just...
No, I just kill the socket. Yeah.
So you notice that that's actually an analysis tool to do other people?
Oh yeah, half open connections. Yeah. But this is, are you saying, is there a question?
I think there might be scenarios where you could actually use that to toss up people.
Oh yeah, absolutely, absolutely.
Maybe inadvertently.
Gotcha. So you're saying, but I'm only going to do this against people that I've already blacklisted.
So I guess the second part of that is what if I can get the blacklist?
Oh yeah, so that's, I mean, if I'm doing a bad job of identification, I think I'm kind of already losing at that. So this assumes that, but you're right, there probably should be a way to blacklist and sort of do it slightly nicer, right? Close connections immediately.
I mean, it's an option, right? There's built-in pros and cons.
Yeah, totally.
And as we move more towards things like carrier-grade NAT, where you've got people coming from large numbers of people coming off of single IP addresses or single IP address spaces, are you planning at all on how you will change your strategy? Because I mean, it's entirely possible that one bad actor at Verizon can take out all of Southern California.
Yeah, totally. And that's sort of what I was getting at with the name, like running at 99%. You're going to try and identify those. And by the way, this is just the proxy. Like, we're not on to the identification stuff yet. So this is the really low-hanging fruit. If you install the proxy right now, it's going to do a pretty decent job of defending against sort of the slow attacks, the slow star attacks. But that doesn't even start to get into sort of identification of malicious actors, which we'll get onto in a sec. So what does aggregator.js do? It links the proxies to the consumers, and it multiplexes every event. So the proxies send down their little JSON string, and then if I connect a consumer on the back end, I get the full stream of those across all of the proxies. So for instance, if I have 300 proxies, right, they're all going to send their events through the aggregator, and every single consumer gets the same set of events. The reason for that is I can now sort of size the back-end consumers to the task at hand. So if I'm keeping a lot of state, I can attach a really powerful server to that and keep a lot of state and make decisions there. And so aggregator is really just a very, very simple pub/sub type server. It's 64 lines of node. It's super simple. And so finally, let's talk about the consumers. And these are the things that you use to actually do the identification. So you're going to write these. And they're drinking from the JSON fire hose. They're getting a lot of data. But again, you're not looking at the payload. You're just looking at headers. So it's a pretty manageable amount, even if you have a pretty high traffic website. These guys are going to make independent decisions. So once they've identified something as a malicious actor, they're going to actually send that command upstream to the aggregator. And they're going to do that through the exact same pub/sub channel that they get their data from. So they just send a command back, and it's multiplexed out to all of those proxies at the same time, meaning as soon as I've identified, it's cut off, as quickly as possible anyway. And some of the commands that the consumers use or utilize are block and unblock. So this is simple. Block. If we block a host, we're going to send that command upstream. It's going to close those sockets immediately, but as you said, maybe it shouldn't do that. We'll take a look at, I think that's a good idea to do it sort of nicer as an option. Gray list, so add something to the gray list, which is, unlike block in that I can block individual URLs. And the individual URLs are disable URL, enable URL. This style may change slightly, but right now it's disable URL. Here, I'll show you an example. Disable URL, puppies in a Santa costume, right? And then I add something to the gray list. So now for 60 seconds, that IP can't download puppies in a Santa costume. And the timeouts, by the way, that come after these commands are all in milliseconds. So once they expire, they're popped out of the array and, pretty simple. H timeout, that's the dynamic header timeout. R timeout is the read timeout. Flush is, I just want to flush my blacklist. So let's go back to nothing. Let's start over. And I more recently added this nuclear option. I call it the nuclear option because you probably don't want to use it. But in this situation where maybe you have a lot of connections, you haven't done any identification, your website's down, you might want to just kill off all these connections and sort of start over. It's not a great user experience for sure, but if you're already down, that's not a great user experience. So what nuclear can let you do is if somebody has built up this sort of slow read connection pool over time, if you cut off all those connections, they at least have to start over. And maybe you can sort of start to identify them again as they're building up their connection pool. So that can be useful, maybe not the best solution. This is what the commands look like. So all of the block and gray commands, you send a pipe and then how many milliseconds you want to block. And that's checked every time. So yes.
Just real quick. Yeah, so if you're in AWS and you're running with ELBs in front of your Apache instances,
Yep.
you don't get real IP.
Yeah, so
You don't get real IP.
in that case, we just look at X forwarded for.
Okay.
Yeah.
Options for other things, like encapsulates as encap IP or whatever.
Yeah, you can trigger off whatever header you want, or there's an extension to do off of other identification mechanisms, but yeah, for the most part, like most people are running behind a load balancer of some type, so X forwarded for is definitely the more useful way to do it, I would say. And the problem there is that like you can't easily kill the connections into ELB as far as I know, so you just have to let them take the brunt of that, unless you put this sort of in front of it, but different sort of discussion there. So let's take a look at an example consumer, and this will be like the dead simplest case of a consumer. This is somebody reading the stream. So let's take a look at this. I mean, this is just the simplest thing. It uses this shared library, and all I'm going to look for is somebody that makes more than, what is it in this case? 75 connections, right? So one IP, one whatever. And again, this isn't going to be the best defense, but it's a start. So let's go ahead and run that. And by the way, let's see what let me do a quick demo here so this is Bouncer running in front of the same site. So this is me connecting straight to the Apache, and then this is Bouncer running in front of it. Roughly the same. And go over here. There we go. So let's attack Bouncer directly, just as another quick demo. So as you can see, we're going to build up this huge number of connections, and the number of connections to Apache is pretty much nil, right? I'm not actually doing anything in this. I'm just doing a slow header attack. These requests aren't actually even making it to Apache because I'm never finishing the request. So this is sort of that slow Loris attack we were talking about. So if we move this to a slow read attack, now you're going to see at least one connection open to the web server. Maybe not. Maybe it's too quick. Oh, sorry. Did I run that? That's a range attack. Sorry. So there you go. So see the one connection that came into Apache. Every once in a while you see one. And that's because Apache is responding really quickly. So the proxy itself actually has the response already cached. And now it's just slowly sending the response back to the tool, right? So in this case, again, the proxy is taking the brunt of the work, and Apache is really doing nothing. And when you're in that mode, I can still load this fine. It works fine. And I have, in this case, 2,000 connections open. So right away, just throwing the proxy in front of it, you get a certain level of defense. So now let's run too many connections. And this is the guy that's looking for 75. And now we'll just do this again. And there you go, simple. It hit 75. I blacklisted the IP, and now any subsequent connections are just dropped. And I think it's going to say, yeah, service available, no. So the tool thinks the website's down, right? Because it can't even open a new socket to it. So in that case, we've identified one malicious actor. In this one, I think I only blocked him for 10 seconds. So he can start doing it again. The other thing, when a host is blacklisted, it's actually going to look at the connection pool and close all of his other connections too. So those previous 75 connections, I'm going to go ahead and cut those off at the same time, right? I don't know if that's a great decision, but I can't imagine why I want to leave those first 75 open, right? So go ahead and kill those too. Oh, I didn't expect that demo to go well. So next simple one is track the pages using the most time, and then track hosts using those pages. And we'll just do this one really quickly, see if it goes. So down here, it's a really verbose statement. Please don't click this link. It's hog server resources, blah, blah, blah. It's actually a sleep 20, so it's not really doing much of anything, but it is going to tie up an Apache. And, oops. So another really simple one, but in this case, which one am I doing? Yeah, the protect URL up there is slow. So I'm just hitting that slow URL. And if anything hits it more than twice, I'm just going to say you can't hit it for 60 more seconds, right? So let's run that one. And then we'll go over here, click this really cool link. So that's loading, right? Because that's fake using server resources, sleep 20. Hit that again. And now, now when I hit slow, this is actually, right, these are still loading. But on this third one, now when I hit it, it's just closing the socket, right? So I've said you can't hit that URL anymore. But, oops. Well, I was going to show you that if I do this, whatever. If I hit any other URL, it works fine. That's the point. So example consumer 3 is where it starts to get a lot cooler. Anyone here use Redis? Okay, so Redis is pretty cool. And it has this data type called sorted sets. And sorted sets are a lot of fun. And what you can do with those is, it's like a standard set in computing, but they're in a rank order based on, you know, how many hits you've had, or you can put them in a rank order. So what you can do is actually decide your granularity. Like, I'm going to store per minute how many hits to this either URL or how many hits from this IP, and then I can actually do unions and joins across those sets later and say, okay, now I want to look at this 30-minute block, or now I want to look at this hour block, right? And when you do that, when you look at the data set that way, you can really start to identify malicious actors sort of after the fact. So I'm not going to actually show you this demo because it takes a little bit more time, but if you're curious about it, ask me. Let's talk about logging. So, you know, right now this stuff is pumped through the aggregator, and you can log it as simply as connecting to the aggregator and then just gzip and put it into a log. You can do it however you want. Some things like Logstash, or I think it's Loggly, you can just shove JSON data into, so that's pretty cool. Some notes on running it. The proxy, you really have to run it with ulimit-n increase to something, because otherwise you'll run out of file descriptors and then it's kind of pointless because you'll be in the same boat as you were with Apache. Node forever is a decent way to daemonize. So you run forever, and then this backgrounds, and you know it'll handle restarting it automatically, which is good. Clock sync is really important. Anyone know why clock sync would be important? No, those are just random. So UUIDs. So the reason clock sync is important is because the proxy itself is generating the timestamp, right? So if one of my proxies is wrong out of say 300, now I have invalid timestamps just being thrown into the data. So you really want to make sure that you're using NTP or something. Did a little performance testing, and this was through an aggregator that was an AWS C1 medium, and we were able to get 62,000 requests a second through it. So that's a pretty good number, and that's again only HTTP headers, but that's a pretty decent sized DoS attack with a pretty medium sized AWS instance. And in this case, I think these only have 100 meg connectivity, so the network was actually saturated before the CPU.
Is that one node process?
Sorry?
Is that one node process?
Yeah, that was one node process. So that was just one aggregator. So you can actually probably, horizontally expand those out, which is also kind of cool. Some other uses for this are weathering a popularity storm. So whatever /dotting is called these days, right? You can probably use this to help mitigate that. And scraper apocalypse. This is another fun story. So we had this weird case where we were getting about 8 million. requests from midnight to 2 a.m. That's odd. And so it turns out these were scrapers, right? And they were looking for particular information on our site, and they were doing it really inefficiently, and this is costing a lot of money. So so all of these, by the way, came from AWS, which made identification really easy because, one, there aren't a lot of IE8 instances in AWS, or a lot of Windows instances that show up as IE8, right? So they were lying and saying, hey, we're IE8 and we just want to view this page. And the other thing that was easy to identify was if you actually took one of these IPs and connected back to port 22, well, guess what? It answered as, SSH. So that's really weird. I mean, maybe they're running Siglin, but I kind of doubt it. And so this allowed us to sort of find those hosts and out them. And after maybe 10 requests, we could just say, okay, we've decided you're part of this scraper pool. And the reason this was important is because the scraper was actually moving so quickly that if you would cut off one of those hosts, they would just pivot to another one right away. I mean, they would just spawn another instance and keep going. So this can be really useful against scrapers. Some future plans. So, this data stream isn't gzipped right now. That's probably a good idea. A bit more operationalization, just making it easier to stand these up in front of your website. It definitely needs a bit more documentation. It's pretty simple, so maybe not a lot more. Some Amazon AMIs, or somebody mentioned maybe Docker as a good way to deploy this. A library of consumers. So I've posted some of these examples are actually right in the code base, and you can run them like too many connections. But as you get more people seeing different types of attack, you can just add those to the example list, and then you can really just deploy those at will. Multicast, maybe. I don't know. I'm not sold on that idea yet. And logging destroyed connections. So just throwing when we actually destroy connections, keeping some log of that event for sort of future reference. Takeaways are denial of service mitigation is easier with a complete picture, right? So that's what I was saying about trying to defend on an individual per Apache basis versus having sort of a broad view of your environment, which I think is kind of helpful. Suggestions are definitely welcome, and any contribution. This is all on GitHub, so any contribution, check out the code here and critique it, and whatever.